Hey there, grade 6. New math video for you guys today. This one focuses on something called continuous line graphs. And so hopefully by the end of the video and then the end of the practice on page 51, you will say that you can use continuous line graphs to predict what happens in between data values when data is continuous. And so I will need to explain what continuous data actually means. And so here's where we're going to start. Just first, a quick review of the difference between discrete or continuous, right? And so discrete data was where there are no values in between the data points, right? So the number of students in a class, right? That is discrete. Height is continuous because it can be all the heights, right? So you're asking yourself, are all the points between the data values possible? Okay, so when the data is continuous on both axes, in other words, if the data is continuous along the x-axis and along the y-axis, then you can draw a line graph with a solid and not a dashed line. So it stops being a broken line graph where one of the axes is continuous and starts being a continuous line graph because both axes are continuous. Okay? And so there are examples of like temperature and days of the week, temperature and days of the week would be a broken line graph, but like time of day versus the temperature, or the time versus, I don't know, like the distance you are from your house, if you're graphing that out. Okay, so you have to just make sure that you're aware of that, that's what a continuous line graph actually is, okay? So I drew a continuous line graph for this data, and again, this is the time and distance from someone's house, and you'll notice that along the x-axis, all these data points it's continuous, right? Because you can have time between 0 to 15, between 15 and 30, and then the distance from someone's house, well, these points between 0 and 1, or say 5 and 6, those are all possible. And so it says to draw arrows to show the points 15, 2, and so that's right here. So 15 minutes into the trip, you're 2 kilometers from the house. 30 minutes into the trip, you are approximately 5 kilometers from the house. You know, so the idea again is that the data along both axes is continuous. Okay, so if you think where 20 minutes is, so 20 minutes is roughly, I would say, like right about here. And if you go straight up, we can imagine he's about 3 kilometers from his house. And again, that's about where he was. Okay. Now, this is another continuous line graph, and this continuous line graph on the x-axis it shows hours worked or time worked. And then on the y-axis, it shows how much money is earned. So the question is, how much money does Iva earn after 3 hours? And I showed you guys with broken line graphs that you can use. You can use a ruler to figure something out, right? And so, after 3 hours, if you use the ruler method, you see that she works 60. If you slide it back after 2 hours, she earns $40. And then, after half an hour, which is roughly right about there, she would earn about $10. If you wanted to do 3.5, you would slide this over to the halfway point between 3 and 4, and then again where the line connects. So we're at about $70. Okay. Now, in case you don't want to use the rulers, in case you find them kind of distracting or you don't like them or whatever, I understand. You can actually just use multiplication, right? You could say, it's 3 hours times $10 an hour, times $20 an hour, 2 hours times $20 an hour, half an hour times $20 an hour, 3.5 times 20, you could do that multiplication to find that out. And it's not impossible. So that's really what we're focusing on. It's not a ton of questions on page 51, but they do all focus on, recognizing the difference between broken line graphs and continuous line graphs, and then using the continuous line graphs to find, value points in between the stuff. So this is the practice. It's not a ton of math today. It's just page 51. But yeah, thanks for watching and have a great day.